Welcome students. We want to discuss the following problem. So find all the positive integer n such that phi of n equals to 10, where phi is the Euler phi function or totient function. So first let's recall the definition. So recall, if n is p1 to the power a1, pr to the power ar, then phi of n is p1 to the power a1 minus 1, pr to the power ar minus 1 times p1 minus 1, p2 minus 1, pr minus 1. So this is the definition of Euler phi function. Now, notice the following. So if p is a prime factor of n, then p minus 1 divides phi of n, right? So p minus 1 should be factor of phi of n. So we have p minus 1. So let p be the prime, p be the prime, which divides n. So in that case, we have p minus 1 divides 10. So therefore, we get p minus 1. The possibilities are 10, 5, 2, 1. Right? Which implies p equals to 11, 6, 3, or 2. Now, 6 is not possible. 6 is not a prime. So 6 is not a prime. So we have 11, 3, or 2 as a possible prime factor of n. So we have restricted our search now. Now, notice that since 11 does not divide phi of n, multiplicity of 11 can be at most 1. What do I mean by multiplicity? That means 11 can only appear with the power 1, not with the power 2. So now let's see. So phi of 11 is already 10. So therefore, what do we get? Therefore, n equals to 11 is one solution. It's one such solution. And now 11 only appears with multiplicity 1. So therefore, if there are other prime factors, let's call them as n. So if n equals to 11m, we have m and 11 are co-prime. Yeah, I'm avoiding the prime factorization for it. So what do we get? We get phi of n equals to phi of 11 times phi of m, because they are co-prime. And we get phi of n is already 10. So this would mean 10 equals to 10 times phi of m. This implies phi of m equals to 1. Now note that this can only happen if m equals to 1 or m equals to 2. So therefore, the other solution is, if m is 2, you would get n equals to 22. So no other factors with 11 in it is possible. No factors with 11 is possible. Or no n, no other n with 11 as a factor, with 11, so no other n with 11 as a factor is possible. So now what are the other primes left out? Then we have the other primes possible are 2 and 3. So now we have, so now 11 is gone. So we have p 2 to the power a times 3 to the power b. If your n is of form 2 to the power a, 3 to the power b, you will get this is same as 2 to the power a minus 1 times 2 minus 1, 3 to the power b minus 1 times 3 minus 1 equals to 10. Now, note that 5 is a factor on this side. So 5 divides 10, but 5 does not divide 2 to the power a, 2 minus 1, 3 to the power b minus 1, 3 minus 1. Therefore, no such possibility, no such n of form 2 to the a and 3 to the b times 2 to the b times 3 to the b can be, no such n of form is a possibility. Therefore, what do we get? Therefore, n is of form n equals to 22 or n equals to 11. So these are the only possibilities. All right. So let's do one more problem. Say solve for phi of x equals to 12. Now, again, if p appears in factorization of x, this implies p minus 1 must divide 12. This means p equals to p minus 1 equals to, let me write down all the factors here, p minus 1 equals to 12. So factors of 12 is, so 12 itself, 6, then 4, then 3, 2, and 1. So this implies p equals to 12, 7, 5, 4 is not a, 3 plus 1 is 4, that is not a possibility, 3 and 2. So these are the possibilities. These primes are possibilities. To appear in the factorization, have possibility to appear in the factorization of x. So p equals to 13, my bad, right? So these are the primes which can appear in the factorization. Now let's start with the 11. Sorry, let's start with 13. So p equals to 13. So note that 13 does not divide 12. So therefore, multiplicity of 13 is 1. Yeah, is can be at most 1. Yeah, we are not sure yet. It can be at most 1. Similarly, by similar argument, you can see that 7 does not divide 12, 5 doesn't divide 12. So multiplicity of 3, 7, or 5 can be at most 1. All right. Now let's start with the biggest prime, which is 13. So when p equals to 13, now p can appear with only multiplicity 1. So now what do we have? We have, if you have m times 13, if n is m times 13, where this is some product of primes, m is some product of prime, we have phi of n equals to phi of 13m, where here m and 13 are co-prime because m is different powers of prime than 13. So we get this is same as phi of 13 times phi of m, because phi is multiplicative function. So we get that is equal to 12 times phi of m. Now that gives us, but phi of n is already 12. This means phi of m equals to 1. This gives me m equals to 2 or m equals to 1. So therefore, n equals to 13 and n equals to 2 times m, which is 2 times 13, which is 26, are possible solutions. So now we have taken care of 13. Now let's go to 7. So again, so 7 appears at most with multiplicity 1 because of this statement here. So similarly, if we have, if n equals to 7L, where L and 7 are coprime, this gives us phi of n equals to phi of 7 times phi of L. Now phi of this is given to us as 12. This is 6 times phi of L. This gives me phi of L equals to 2. Now we already know what are the such possible solutions. So in that case, your L either is 3 because phi of L is this, or it is basically, or L is 4, right? Because since phi of 4 is 2, or L equals to 6. Why? Because phi of 6 is phi of 3 times phi of 2, which is going to give me 2 times 1. So what do we get? Therefore, we have L equals to 6, 3, or 4, which gives me N equals to 7, 6 are 42, 21, or 28. So these are also possible solutions. Now let's work with n equals to 5L, 5 times O, right? So you see here 5 also appears with multiplicity 1. So let's say this is going to be 5O, where theta and 5 equals to G3 is 1. Then we have phi of n equals to phi of 5 times phi of theta. On one hand, this is given to us as 12. On the other hand, here we get this is equal to 4 times phi of theta. This means phi of theta equals to 3, and we know that this has no solution because phi of x is even or 1. Yeah. So phi of x can be the only, phi of x. So what are the possibilities for phi of x? So phi of x can be even, or only odd number which is allowed to be phi of x is 1. Okay. Now comes the possibility. So 5 is taken care of with its different factors. So now what are the prime factors which remain? The prime powers which remain is n is of form 2 to the power a, 3 to the power b. Let's work this out. So P of n on one hand is given to us as 12. And on the other hand, we have 2 to the power a minus 1 times 2 minus 1, 3 to the power b minus 1 times 3 minus 1. So we get, here we get the following. We get 2 to the power a minus 1 times 3b minus 1. Now here, you notice that 3 divides. So let's write down the factorization of this guy. So 2 to the power 2, 3 to the power 1, right? So this clearly means that b minus 1 is 1. That means b equals to 2. So in that case, if you cancel that off, you will get 2 to the power 2. So you cancel this guys off from both sides. You'll get 2 equals to 2 to the power a minus 1. So therefore, a equals to 2 to the power 1 equals to this guy. So we get a equals to 2. So in that case, n will be 2 to the power 2, which is 4, and 3 to the power 2, which is 3 to the power 2, which is 4, 9s, which is what, 36. So these are all the possible solutions for your phi of x equals to 12. Now note that you don't need to start with the larger prime here. You can work with the prime factorizations directly. Okay. So it will be interesting to see the following. So let's try it. So try phi of x equals to 16, 1, and say phi of x equals to 21. Thank you for your attention.